week, I teach this section again, because this is very, very important, okay? So just to remind you that how important this method is going to be. Now, the method of substitution. So this is, as I talk about it, we are not going to skip anything, but this is the order that it must be, not the one that's in your book. So we take it, in your book it's a 4.5, but no worry, we have to get it first because we want to make sure that we have enough time to practice for this one. And this is one of those great calculus book. Larson is the only one that they don't talk about it in 4.2. Okay, that's it. It's called integration by substitution. Integration by substitution. Substitution method. Sometimes we give it a hint, so you must know the name. Okay. Integration by substitution. Among the students, they usually refer to it as U subs. U substitution, if you like, or U subs. Just in short. You will see why we call it U sub. Okay, now what it is, it's just the converse of the chain rule, method that we did before. Remember the chain rule? Let's remind you. So in the chain rule, recall that. Okay, recall that. It would be typically can be applied to this type of function. By the, okay, recall that by the chain rule. By the chain rule formula, just remind you. Remember, if you want to find the derivative of this function, if f of x happen to be 3x plus 1 to the 6, remember, then what's going to be the formula for this one? The formula is f prime of x. Remember, we take this one as u to the 6. So it was 6u, okay, to the n minus 1, which is 5, times u prime. So we bring the power down, it's going to be 6, 3x plus 1 to the 5th times u prime. U prime was 3. Okay, that's the way we did the chain rule over here. Now remember, antiderivative or indefinite integral is the opposite operation. So what's going to be the opposite of this operation? The opposite of this operation would be equivalently. You see, you differentiate this function, you get the f prime. The opposite operation is if you integrate this part, you should get the function. Okay, so opposite would be integral of a 6, or antiderivative, 6 times 3x plus 1 to the 6 times 3 dx must be equal to what? Must be equal to this function. Must be equal to the 3x plus 1 to the 6. But we add the constant c to bring all the possibility. That's all equivalent. You know that if you want to check that this is true, you differentiate the term to the right, and you might guess the term to the left. Okay, but let's do a little bit of algebra here. So what I'm going to do, the algebra part, I'm going to just, let's bring this 6 out. So I bring the 6 out. It's going to be integral of a 3x plus 1 to the 6. And I put these 3 and the dx together, you see, 3 dx. And this is going to be 3x plus 1 to the 6 plus c again. Okay, you know that it's a constant. I can put it out. What else I'm going to do is I'm going to divide both sides by 6. Okay, if I divide both sides by 6, so that gives me 3x plus 1. 3x plus 1 to the 6 times 3 dx, okay? 3 dx, and this is going to be 3x plus 1 to the 6, then divided by 6 plus the constant c. Since it's a constant c, it doesn't matter. Even if you divide by 6, you can call it a constant c. You can call it c1, c2, okay? So let's see this, what is going to be this one in the language of the chain rule formula. Remember, In the chain rule, this is going to be the one. If you call this one 3x plus 1, so if 3x plus 1, if you call 3x plus 1 to be u, okay, this is going to be u. So your u is what? Your u is 3x plus 1. So what's going to be differential of the u? Remember, differential of the u, differential is what? Differential is the derivative. Okay, just remind you, if the u is going to be 3x plus 1, okay, differential of the u. Differential of the u is u prime times dx. Remember, differential, you differentiate, you times it by the dx. Now what's going to be u prime? U prime is 3. So in this case, your du would be what? Would be 3 dx. So I take u to be 3x plus 1. This 3 dx would be what? This 3 dx would be simply, it's simply u prime dx. Okay, u prime dx. So this is going to be u prime dx. Okay, now, what I'm going to get on the other side? On the other side, this would be changed. This is u. So that give me u to the 6, okay, over 6 plus c. So if I go back and substitute whatever I have, okay, I missed something here, but just that was a 5. Okay, sorry about that. I missed the 5 here. So this is 5. Okay, this is 5. This is 5. And this is 5. Okay, because I reduced the power. So in the language of the u, if you change it to the u form, what's going to be the result? And the result is going to be, I have the integral of u to the 5th. Okay, integral of the u to the 5th times it by u prime dx. Okay, and this is going to be simply u to the 6 over 6 plus c. Okay, but u prime dx is just a differential of the u. Remember, this is the du. So what I have is, this is it. I have a u to the 5th. Du is equal to the u to the 6 over 6 plus the constant c. You see this formula? What is this? This is just the power rule. Remember the power rule? U to the 5th du, action of integration. You add 1 unit to the top, make it u to the 6 divided by 6 plus c. So this is going to be called, when you change it to this format, we got to use substitution method. So what we do is we are going to create that one first, you see? As soon as we see this problem at the beginning, we are going to take the u, you see if this is going to be given to you. So we take this one to be u. We say this is u to the 5th. So we have to change it to the u to the 5th du. If you change it u to the 5th du, this is just the action of integration. Action of integration is you raise 1. You see, you raise the power by 1 unit, u to the 6 over 6. Okay, so it's just like the power rule that we did before. So if you have integral of x to the n dx, like the chain rule, x to the n dx, action of integration would be u to the x to the 6 over 6 plus c. If you have u to the 5th du, it's going to be u to the 6 over 6. If you have t to the 6 dt, it's going to be t to the 6 over 6. So as you can see, we arrive at the kind of, we call it the generalization of the power rule. So the conclusion is going to be, you see the conclusion of this argument, simply, see we get it free. Simply the conclusion is going to be this one, that in general, okay, it can be getting more involved, but we do it step by step. In general, if u equal to the u of x, to emphasize that this is a function of x, is a differentiable function, okay, if this is going to be a differentiable function, then we have the generalization of the formula, differentiable function of x. Okay, then what we have is this one, integral of u to the n du is equal to 1 up u to the n plus 1 over n plus 1 plus the constant c. Of course, anytime except when n is equal to -1. You need natural log. We'll talk about natural log later. we go according to your book. So for the time being, it's not going to be happening at the negative one. But you have to emphasize that this is it, where this differential of the u is simply u prime dx. So this is the formula for the, finding the du. It's a part of a great theorem in calculus that we call it change of variable. So we change the variable from x to the u. When you do it, we say you have to pay for it. There is going to be an extra term. That extra term is this u prime. This extra term in general, in calculus, we refer to it as a Jacobian. In the case of the function of one variable, it's easy, it's u prime. But if you take calculus 3, your function with a function of 2 variables or 3 variables, and your integral is going to be double integral or triple integral, we call it. And this formula would be a little bit more involved. It's going to be something like, there is a special matrix, if you know, familiar with that notion, we call it Jacobian. But in this course, you don't need to bother about those type of ideas. Okay, so we are going to refer to this, okay? We refer to it as the general power rule. Okay, it's like the differentiation that you did, the general power rule, okay, for integration. Okay, so as you can see, the formula is something natural that we have seen, we can see it. So when are you going to use it? You are going to use it when this is going to be u is going to be kind of a function that you use for the chain rule function. Okay, it's a function of x. So it's going to be inside the parentheses, inside the radical, maybe down the denominator, inside the sine, cosine. So anytime we can change it. But anytime you change, your difficulty is something to not to remember is this du over here. Okay, so that's a general idea. So we have to practice to see how we're going to apply it. So the function would be given to you. See, this is going to be the one. This function would be given, this integral. As soon as you see of this format, we say it's a chain rule type because there is a parenthesis, something in it. Something in it, you call it u 3x plus 1. Then you have to go on, this is u, you find the du, u prime dx, you go substitute. If you've done everything all right, you must arrive at u to the 5th, whatever power is here. U to the 5th du. As soon as you make it into the u to the 5th du, action of integration is you raise it by 1 unit and you divide, and then you're done. Okay, so that's a general idea. Any question? I'm going to do it for you. I'll show you 2 different methods. The method that we usually use in calculus 1, and there is a shortcut that you can apply. If you intend to take calculus 2 and calculus 3, it's not bad, But in calculus 1, we play it safe and we do the substitution. Okay. So let's write. There are kind of 5 possibilities for the time being, and there are going to be 2 more. When we get to the next chapter, altogether 7 types, and you will see all of them on your next test. And on the final. But you get quite a lot from the substitution method. Let's see how we're going to operate with this method. It's a easy method as I talk about it. So we give you all the possibilities, and then most of the time you are going to be told that apply the method of substitution, or they are such a clear functions, really. It's not going to be difficult to recognize it. And you have to do all the operation over here for me, on the test. We don't accept it if you don't show your work, because, all the calculators can give you the result in a matter of seconds. But when we say method of substitution, means you do it, you show us your substitution steps, because it's going to be 7 questions from this one. So be careful, give us all the details. Otherwise, you will lose all the points if you don't give us the details of your work. Okay, are you ready? There you are. Find each integral. Each integral by substitution method, by sub. Use subs, they call it, substitution. We give you the instruction, so you will find out, sometimes they say substitution method or just substitution. Okay, that is method. There you are. Type 1. Integral of 5 times, okay, 5 times 5x plus 2 to the 10 dx. You say as soon as you see a parenthesis raised to something, it must be done by u substitution. That's it. You don't even to be told. U substitution because there is a parenthesis. Of course, you know, if you want a square, you can square it, but it's 10, it's difficult. Or you may say, I can do it, so I change this one to the 1000. Then you never be able to do it, okay? Besides substitution method. So this is how you identify the method easily. You say, oh, I need to do the substitution method. What is my u? The inside. So you identify the u. U is 5x plus 2. You say as soon as you identify it, you are going to have a target. Your target is you have to change this one into what? U to the 10. U to the 10 du. This is your target. This means you go back and nicely substitute. If you get u to the 10 du, you know that it's going to be u to the 11 over 11. So what I'm going to do, you need we substitute for everything. We have to substitute for dx. You find the du first. Du, differential of the u. I remind you, it's a u prime times a dx. That's your formula. Du, derivative of 5x plus 2 is just 5, times it by dx. Then solve for dx. Get the dx out, you divide by 5. So that gives you dx equal to the du over 5. You are going to do these 2 steps on all the coming problem. Okay, take the u to be 5x plus 2. Set the target for yourself. You must get u to the 10 du. You don't have to write this one. This is the way I do it. Then you have to find the dx because everything must be changed into the u. So dx, you take the differential of the u is the u prime times dx. U prime is 5 dx. Then you have to solve for dx. You divide by 5. Go back, substitute. Substitute originally, you have 5 times 5x plus 2 to the 10 dx is equal to substitute. 5 is the 5. You see, 5x plus 2 is the one that you call it u. So it's u to the 10. U to the 10. That is u to the 10. Then you have what? You have the du. What is going to be your du? Sorry, you have the dx. What's the dx? Dx is du over 5. You see, you times it by du over 5. Any question? Now you get a chance to simplify this too. You simplify it, you get your target. You see, u to the 10 du. U to the 10 dx, the target. Any question? The rest is clear. Action of integration. You add 1 unit up. That would be u to the 11. Okay, u to the 11 over 11 plus the constancy. Action of integration is just the power. But you have to get back and substitute for u. So your final answer is the integral 5 times 5x plus 2 to the 10 dx is going to be equal to the u. Remember, u is 5x plus 2. 5x plus 2 to the 11 over 11 plus the constancy, and you are done. Any question? Very nice method, but you have to give us all the details. So it's a U type, we call it. I explain it again. It's a 5x plus inside the parentheses. You take this one to be u, you have to change it into the u to the 10 du. You need the dx. You differentiate it, du would be u prime dx. U prime is 5 dx. You solve for dx. Dx is du divided by 5. You go back and substitute. 5, this would be u to the 10 dx. You substitute. These 2 would cancel out. These 2 would cancel out. The leftover is u to the 10 du as you plan it. So that gives the final answer. Any question? Now, there is another method to do the short form that, When I teach calculus 2 or calculus 3, I use these methods. Okay, if you can do it, I don't mind. But I just want to remind you, when I do it in calculus 2 and 3, the people say, oh, I haven't seen this method. This is in your book, okay? And this is inside. So just for your information, or it's very good to know. You see, we can shorten this method if you like. Now what's going to be this? You see, this is the integral that you have. You have 5 times 5x plus 2 to the 10 dx. You see, the way we did it, you take this one to be u. Okay, this is going to be u. Remember, when you do the chain rule, there is going to be u prime, or when you do the differential of the u. So you look for the u prime. You see, u prime is 5. So this is going to be 5. Okay. So what I'm going to do is I'm going to put the u prime and the dx together. So I rewrite it. And this is going to be 5x plus 2 to the 10. Then I put the 5 and the dx together, 5 and the dx together. That's it. Remember, this is u. This is u. What is this one? You see, this is going to be u prime, 5 times dx. Look at this one, 5 times dx is simply du. So what you created is just u to the 10. You see, you create this one right here. So you have u to the 10, u to the 10 du. U to the 10 du, just action of integration. We add 1 unit to the power. Okay, so this is going to be equal to u to the 11 over 11, which is 5x plus 2 to the 11 over 11, and a constant c, and you done. You see, this is the way we expect you to do it in future. Okay, when I teach these courses, calculus 2 and 3, because this is going to be part of the solution. You may have one problem, then you have to do several of these substitution in that problem. So, we just see it, but you get the experience and you'll be able to do it. But you can play it safe in calculus 1 and do the operation for us. But if you want to do this one, exactly, you have to explain it. There is a catch here that, there are some cases that you need a little bit more experience to be able to do it, but it's not bad. Okay, because as soon as you get the u prime, you say we have a deal. Because we put the u prime and the dx together, that would be du. So this is like u to the 10 du already. U to the 10 du would be u 11 over 11 plus the constant c, and then, then you're done. Okay, so
I have
this
a question.
Yes.
Why wouldn't you pull out a 1/5 for that one? Where the 5 is hanging out in front, pull out a 1/5 of the integral?
No. Why 1/5?
To have the 5s cancel out.
No, I need the 5. You see, I need the 5 for the du.
Oh, because it's paired with the dx. Okay.
Yeah. The one that you think about it is going to be the next one. You see, if this 5 was missing, let me just give you that the other example I show you. But in this part, you shouldn't drop it. You shouldn't pull it out, because all these problems depend on the u prime. Because if you have the u prime, you pair it with the dx, you get the du done. Okay, so that's why we keep the 5 here. We keep the 5 here, and then we do the job. Okay, let me just give you.
I see. Thank you.
Yeah, it is going to be the one. The only difficulty is when this 5 is missing. Then I show you. Okay, so that's type 1. Any question? Let's go to the type 2. And we give you one from each. What's the type 2? The type 2, of course, as we differentiate, is the radical function. Okay, if you have something like integral of cube root, okay, 4x plus 2 dx. Remember, when you want to differentiate this one, we remove the radical, we rewrite it. Do the same thing over here. As soon as we rewrite it, we create 4x plus 2 to the 1/3. 4x plus 2 to the 1/3 is exactly, the previous one. So any radical, as we talk about it all the time in this course, we don't like the radical, either when you want to differentiate or you want to integrate it. So there you are, rewrite it first. So if you rewrite it, this is what you need. So it's a cube root of 4x plus 2 dx. So you change it to the 4x plus 2 to a third dx. Now you know what to do. You see, you take this one to be u. So your target would be what? The target would be u to the 1/3 du. So if you do the substitution, you must arrive at u to the 1/3 du. And u to the 1/3, you know that you move it up. U to the 1/3 plus 1 would be 4/3 over 4/3, and then you done. So let's create it. Any question? So I go to the next page. I know what I'm looking for. So I take this one to be u, and then I give you the shortcut for this one. Is interesting to see. Okay. So this is what we have now. We work with the new form. This is the 4x plus 2 to the 1/3 that you want to work with. So inside parentheses always going to be u. So this is going to be your u, 4x plus 2. That's a step 1. Step 2, you have to solve for, I'm sorry, I missed the dx here, the dx. Step 2 is to get the dx, so you find the du. Du is derivative. Derivative would be 4 times dx. Then you solve for dx, so the dx would be du over 4. That's the step 1 that you have to do for all the problems. Any question? Go back, substitute to get your target. So originally we have 4x plus 2 to a third dx. Okay, now substitute. 4x plus 2 is u, is going to be u to the 1/3 times it by dx. Your dx is du divided by 4. You see, there is nothing to simplify here. So there is a leftover. The leftover is a quarter. So we rewrite it as a quarter, u to the 1/3 du. Remember, your target was u to the 1/3 du. You have a quarter, you pull it out. So that gives you a quarter. You see, a quarter, u to the 1/3 du. We got the target. Any question? So it would happen if they're not going to be simplified, we can put it out of the integral because they are going to be constant numbers. Okay, a quarter out. Now we have the target, u to the 1/3. So add the 1 to the top. It's going to be u to the 1/3 plus 1 would be 4/3. Okay, over the 4/3, of course, plus the constant c. You have to simplify it. Remember this number, you get the reciprocal, you move it up. So you get a quarter times it by reciprocal would be 3/4. Okay, so that gives you 3/4 and u to the 4/3. 4/3 plus the constant c. We cannot simplify it, we multiply them together. So that gives us a 3, 4 times 4, 16. So u to the 4/3 plus the constant c. But of course, you have to substitute. So what's going to be the final answer is going to be 4x plus 2 to the 1/3 and dx. But it's happened to be 316. Okay, 4x, this would be the final answer. Remember, you have to substitute. So that gives you the final answer. Okay, very, very important case. Case with the radical. It's very popular, and we see quite a lot of this. Any question? So again, you rewrite it. It's a type 1 again, like the differentiation. So your target would be u to the 1/3. So you take the inside u. You have to find the dx, differential of the u, solve for dx, go back, substitute. The difference between this problem and the previous one was, in the previous one, the numbers was canceled out. In this case, the number is going to be left over. 1/4. 1/4, we put it out quickly. But I rewrite it so that you can see it. So put it out to get your target. U to the 1/3 du, then action of integration and the substitution. Any question? Now, if you want to do that shortcut, there is a trick that you have to know. You see the method 2. Let's see what's going to be the difference. The method 2, we take it from here. You see, that is 4x plus 2 to the 1/3 dx. You need the u prime to match it with the dx to get the du. So this is going to be your u. You see, if you take your u to be 4x plus 2, u prime would be 4. You see, you need the 4 here. 4 is missing. You see, u prime is missing. You need that number here. But when it's a missing part is the number, we can create it. You see, you need the 4 times here. So what we do is, you imagine there is a 1 here, for example. If you imagine 1 is 4 over 4. So we can keep the 4 inside, a quarter outside. Or in general, you need the 4 here. So what we do, we divide the outside by 4, and we divide the inside by 4. We multiply the inside by 4. If you need the 5, a 5 times 5. If you need the 7, a 7 times 7. Okay, so that gives you 4x plus 2 to a 1/3 dx. You see, now we can match them together. This is u. This is your u prime. So pair the u prime and the, okay, u prime and the dx. So it's going to be a quarter integral of 4x plus 2 to the 3rd. So you pair what? You pair the 4 and the dx. 4 and the dx. You see, now you have it. This is u. This is du. So you arrive, you get quickly this part that you got here. So you have a quarter, and this is u to the 1/3. Action of integration, you just add the power. So it's going to be a quarter u 4x plus 2 to the 1/3 plus 1, 4/3 over the 4/3 plus the constant c. Use the reciprocal and simplify it. So it's going to be a quarter. That gives you 3/4. 4x plus 2 to a 4/3 plus the constant c. So this would be 3 over 16. As you know, same solution. 3 over 16. 3 over 16, 4x plus 2 to the 4/3 plus the constant c, and then you're done. You see, the only trick is this one. It's quite popular, even if you don't want to use it now. If you want to take calculus, to make sure you're aware of this type of techniques that we do. Okay, it can be done when it's a number all the time, and the missing part is going to be a number. So whatever number it's missing, just put it here, then divide. You can divide and multiply by a number. You need a 4, 4, a quarter. You need a 5, 5, a fifth, 7, a 7. That would be, but again, the safest one is just that use substitution. But if you want to do this one, I recommend it to learn it. And it would be very, very nice method. Okay, any question? So that's a type 2. Type 2, you got it with the radical function, okay? It's like the way we differentiate the chain rule. What's going to be the next one? Remember, the next one is a quotient function. And the quotient function, how we're going to handle the quotient function, number 3. Number 3 is this one, integral of x squared, okay, over x squared over x cubed plus 1 to the 5th and the dx. Remember, as I talked about it before, I told you that when there is a power here, move it up. You must move it up now. Remember, in the case of differentiation, some of you didn't like it. You try to use the quotient rule, but you can't do this one over for these problems. You must move it up. Okay, you move it up. When you move it up, it's going to be just the previous method. And then you're done. Okay, so we have to rewrite it. So we're going to rewrite it. Solution. This is the original one. If you don't like to repeat the original one, you can call it I and just say I equal to. So it's going to be x cubed plus 1 to the 5th. So you move it up. Move it up means it's going to be x squared, x cubed plus 1 to the -5 dx. That's it. You take this one to be u. What is the target? The target would be u to the -5 du. You see? Because when you do use substitution, so that will help you, that you know that you must get this one. Any question? So remember, you must rewrite it, otherwise you can't do it. You have to move it up. Now let's work on this one as usual. Let's repeat it. So inside would be u we have to find the du. So the du would be the derivative 3x squared times the dx. And we have to find the dx. You see, you divide by the leftover 3x squared. So the dx is equal to the du over 3x squared. Okay, that's it. So go back, substitute. If you have done anything all right, you must get your target. So this is what we need to substitute. So we have the x squared times x cubed plus 1 to the negative 5 dx. Substitute. You don't have any to substitute for x squared. It doesn't matter. Inside, you call it u to the negative 5 times the dx. What is the dx? The dx is the du over 3x squared, you see. Now, x squared and x squared would cancel out. What is the leftover? 1/3. We know that we can put it out. We put it up in front and we put it out. We do it quickly. So this is going to be 1/3 u to the negative 5 du, the target. You see, the target that you set up here. Any question? So be careful over here. You see, that's going to be your du is 3x squared times dx. We find the dx. When you substitute x squared and x squared will be canceled out. Otherwise, you'll be in trouble. Then the leftover is a number, 1/3. 1/3, you put it out. Now the rest, just the power rule, is a 1/3.
Professor?
Yes.
Is it okay if we immediately pull that 1/3 out, or do we need to show that?
Yeah. You have to show this,
okay.
Then you can do it right away.
Okay.
Then it's going to be, so the u would be u to the negative 5 plus 1 negative 4, okay, over a negative 4 plus the constant c. But remember, no negative power, no negative number. So negative positive would be negative fraction. You bring this one down. 3 times 4 would be 12. 1, 12, u to the, okay, u to the 4th. U to the 4th plus c. Okay, but I know that you are not done. You have to substitute for the u to get the final answer. So the substitution would be negative 1 over 12 times u. What was u? U is x cubed plus 1 to the 4th plus the constant c. This would be your final answer. I usually rewrite it, you don't have to. So I have the original one is x squared over x cubed plus 1 to the 5th dx. Then I change it into what? It's going to be 1 over 12 x cubed plus 1 to the 4th plus the constant c, and you're done. Okay, it's a very popular case, the rational case that we're going to have. It's going to be a very popular one, and you got to be careful to be able to get this one through. Any question? So we have to rewrite it. We move it up. Okay, we move it up, and then as soon as you move it up, it's going to be just the same problem that you did before, really. You have to take the u, just look for the dx, and when you simplify it, you shouldn't get anything. You see, you cannot have x and the u at the same time, remember. You cannot have x and the u at the same time. So these x's must be disappear. Otherwise, there is something wrong with your operation that you're going to have. Okay, so this fraction one, if you want to make it more fun, you can bring a couple of trigonometric functions. So we give you another one. It's very popular with the trigonometry. Again, that shortcut, it's the same thing. You see, the shortcut that you want to do is you need a 3 here. So you have to multiply by 3, divide by 3, 1/3, and then do the job as I did it. But this is a safe one. Okay. Now, kind of the VIP types are the types that you get, a couple of trigonometric functions. So let's try one. So that would be our third one, the fourth. The fourth one is this. just secant square on the top. Okay, and then the bottom is 3 plus tangent 10x, everything to the 6 dx. Again, it's a rational function. Remember, we have to rewrite it. You have to move it up, and there is a parenthesis. Of course, you have to use the U substitution. So rewrite it first. Solution. So that's the original one. Secant. You can start rewriting it right away. We don't mind. But I explained. Okay, this is the original one. Rewriting, you move it up. So that gives you secant square of x times 3 plus 10x to the negative 6 dx. That's it. Again, you get a parenthesis raised to something, you call this one u. If you call it u, the target is going to be integral of u to the negative 6 du. You have to arrive at this one. Okay, then we started over. U is 3 plus 10x. That's your u. Differential of the u, du. Du is the derivative. Derivative of 3 is 0. Derivative of a tangent is secant squared. So it's going to be secant square of x times it by dx. And you have to find the dx. You divide by secant squared. So your dx is going to be du divided by secant square of x. Okay. So if you go back and drop this, you get the target. Any question? So it doesn't matter really. You have it. These trigonometric function around. They are would be fun, but we can do it. So let's start from here. Substitute to see if you can get you to the negative 6. So originally we have a secant square of x times it by 3 plus 10x to the negative 6 dx. I substitute. I don't have anything to substitute for secant squared. So secant squared stay as is. And we call this one u, so that would be u to the negative 6. Then we have to substitute for dx. The dx is what? The dx is the du over secant squared. These two would cancel out. And you get your target. U to the negative 6. Okay, negative 6 du. Any question? Of course, action of integration would give you what? It would give you, this is it, u up, 1 up. Negative 6 plus 1 would be negative 5 over negative 5 plus the constant c. And you have to change these. Okay, this would be a sign of the fraction. And you are going to bring it down 1 over 5 u to the 5th plus c. Then you have to substitute for u. So it's going to be negative 1 over 5 times u. What is the u? U is 3 plus tangent x, 3 plus tan x. Okay, 3 plus tan x to the 5th. And the constant c. So that would be the final answer. Okay, again, you don't have to rewrite it, but I do it. Secant square of x over 3 plus 10x to the 6 dx is simply 1 over 5 times 3 plus 10x to the 5th plus the constant c for a record. The final answer. Okay, very popular case with the trigonometric function. Okay, any question? You see that short form is great for this one. Look at the short form. Remember the short form? You call this one u. You look for the u prime. What's u prime? Derivative of 3 plus 10x would be secant square. It's already there. You switch it. Let me write it down for you so you can get these numbers. That would be very useful to know, and you can apply it. Okay, so the short form, the way we do it in future, this is the way we do it. So the method 2, if you like, just for your information. Method 2. In the method 2, you have to rewrite it. You have the secant square of x, okay, times 3 plus tan x. You started from here. That was a -6. You see, in this method, you have to pair u prime and the dx to create the du. So you call this one u. You look for the u prime. Oh, u prime is here. So I'm lucky. So I pair it, you switch it. You have to rewrite it and show us. 3 plus tan x to the -6. Now I have what? I have a secant square of x dx. There you are. This is u. And this is du. So I have u to the -6, action of integration. You add 1 unit to the power, which is going to be 3 plus tan x to the -5, and then you divide, plus the constant c. No negative power, so you bring the top down, minus 1 over 5 times 3 plus tan x to the 5th, plus c. You're done. You see, we do all those operations in one setting, if you like. This type of, especially for trigonometric one, we get very, very much involved, not in calculus 1. But in general, that's a good feeling that, you have to pay the u prime and the u prime and the dx. That will give you du. As soon as you have the du, you already got the power of the u. So you need the u du to be able, to be able to do it. So get to know them, it's good to get to be able to get through this one. Okay, any question? Now, there is going to be one famous format of this trigonometric function. Remember, the one that we did over here for trigonometric function, the angle is, you see, we get the x here. Remember, when we differentiate it, you may get 2x, you may get 5x. So I'm going to take care of those type of integral. So I'm going to, remember, if you have an integral of, if you want to find the derivative of sine of the 2x, so it was a composition of two functions. We differentiate outside, inside. So if you change it to this change of variable format, you are going to have the following formula. Just give you a remark. Okay, remark is exactly the formula that we did before for the trigonometric function. So again, I just make one of them. So recall that, you see. Recall that. If u equal to the u of x again is a differentiable function, function of x, then by the chain rule, then by the chain rule formula, remember we have something like derivative of sine u prime. Remember, it was a composition of two functions. So derivative of the outside times the inside. What's the outside? Derivative of sine, cosine. Cosine u times the derivative of the inside. Derivative of the inside is what? Derivative of inside is u prime. So if you change it to the integral, equivalently integral of the other way around. Integral of a cosine of u prime dx is equal to the sine of u. Let's see. You know the integral of a cosine is sine. But if it's not going to be sine x anything else, then you need the u prime. But you know that u prime dx is what? Bet du again is u prime dx. So your formula would be what? Integral of a cosine of u du is going to be sine of u. plus c. So all the formula that you did have before, it's going to be the same here. So in the case of this type of problem, you take the u to be inside angle. Okay, so similarly, you have the other one. I'm going to list all of them for you. You see, your list is going to be the following. The first one, integral of sine u du. Remember, you want to find a function whose derivative is sine. The integral of a sine is negative cosine of u plus c. That's the first one. The second one, what is the integral of a cosine of u du? You want to find a function whose derivative is cosine, so that function is sine. The third one, integral of secant square of u. You want to find the function whose derivative is secant square. That function is tangent, u plus c. And the last one, so far, integral of secant tan, secant of u, tangent of u, du. You want to find the function whose derivative is going to be secant tan. That function is secant u plus the constant c. So everything you did before, okay, you did it for the differentiation of this type of function, trigonometric function, the chain rule. We are going to see it again here. So the way we are going to recognize it is, if this is not going to be x inside, anything else, you are going to take that one to be your u. Then you do the same procedure. Okay, it's very unique problem for the time being, but it's going to be quite a lot when we get to the calculus 2. So this is going to be the next group that you have to know them. So let's get one of them at least. They are very unique and nothing to worry about for the time being. There is a case with the tangent and the secant that you have to be worried about, but we talk about it when we get the natural log function. Okay, so this would be our next example. Okay, and one of them would be given to. It's very popular. There are a couple of applications. We have something we call temperature function, and we are going to use it. And there is going to be a short form that I'm going to let it know the short form as well, because this is used in science. There you are. Let's try one of them and then we give a break and we come back and finish. Okay, so this is it. We wanted to evaluate each integral. Evaluate each integral. Okay, again by substitution. Substitution. With the substitution method, you have no other choice. There you are. You see this one? Suppose you want to find the integral of x squared sine of x cubed dx. See, quickly you find out that it must be done by substitution method, because you can do sine x. It's not sine x, it's sine x cubed. So what you have to do is you have to take the inside to be u, and your target would be integral of a sine u. Okay, so they give you something other than the x here. If there is going to be something other than the x, so you have to use the u substitution to get it. Okay, so this is going to be your solution. That's it. So what you do is you take the inside to be u. So your u is going to be x cubed. What's the target? The target is you have to change it into the sine u du. You see, if you won't be able to do it, means you made a mistake. Okay, so find the du, differential of the u, differentiate 3x squared is the derivative times dx. And you have to solve for the dx. Dx would be du over 3x squared. as we did for the others, but you must know that you have to take the inside. Okay, so you go back substitute, you must get the target. So originally, x squared sine of x cubed dx equal to, you don't have anything to substitute for x squared, no worry. X squared sine of, but x cubed is your u, it's going to be u. But remember, you have to multiply by dx. What is the dx? du over 3x squared. Now the x squared and x squared would cancel out. Left over 1/3. So it's going to be 1/3 integral of sine u du, as we predicted. Okay, and you know that integral of a sine would be negative cosine. So that given negative 1/3 cosine of u, you have to bring this formula, you must know them. Okay, plus the constant c. You substitute, your u is x cubed. So integral of x squared sine of x cubed dx is what? Is negative 1/3. Negative 1/3 cosine of the x cube plus the constant c, and then you're done. You see, very, very popular case for the trigonometric function. So the way we apply the u substitution for this, the group of function, is the fact that if this is not going to be x, anything else, if it's going to be anything else, you're going to call it u. Okay, you call it u, and then you change it to the sine u. The rest of the procedure is going to be the same thing. If you want to do this one in the short form, not bad to know. Okay, method 2, in case you like this. Okay, for future, you see this one. But you know, the substitution, I've seen some people, they do it even in calculus 3. They give all the details, we don't mind. But it's nice to know. This is the short form. Okay, the short form is going to be, again, remember you have to match the pair, the u prime and the dx. You take this one to be u. U prime would be 3x squared. So a 3 is missing here, you see? Because you need the 3x squared. So how are you going to create the 3x squared with 3? We talk about it. You see this x squared sine of x cubed dx. So you need a 3. Okay, you divide the outside by 3. And you multiply the inside by 3. Because eventually these two would cancel out. So you haven't done anything wrong. Okay, but that gives you prime. Sine of x cubed dx. So now you have it. You see this is u. This is u prime. So pair the u prime and the dx together. So that gives you 1/3 integral of sine of x cubed times it by what? Times it by 3x squared and dx. Now you got it. This is du. And this is simply what? This is going to be sine u. You know that the integral of a sine is a negative cosine. So we get the negative 1/3 cosine. Cosine of what? Cosine of x cubed. Plus the constant c, and you got it. It's the same operation, but you just shrink it if you like. It's a very good method, okay? Especially for trigonometric function. Because there are going to be so many of those, you know, if you want to take calculus to it. So that will help you, but you know, it's safe to do those operations and do it. But if you want to do this one, you have to give us these details. We don't accept if you just give us the final answer. Okay, you have to go through those details. Okay, that would be trigonometric one. Any question? There is another group of the that we use in science. I'll give you a break now. We come back. I'll list those two for you as well, because that would be very useful for us. We have the application problems that we have to use calculator. So we are not going to, you know, waste times, if you like, or some details that going to be clear, or we can, predict it. So as I told you, this is a very important topic. So we give you all the details. It's up to you whether you want to use it or not, okay, or you feel comfortable to do it. But the general substitution method is always available. Okay, so it's a 9:12. We come back about 10, 15 minutes, and then I should give you another short form or group of this. And there is one very special one. We have to talk about it. Then we finish it, the substitution method. We come back to it again. We have one more integral, we call it definite integral, but the reason is, as you can see, this is a very important machine. That's why we bring it up forward, if you like. So we get enough time to practice before the final. So let's have a break. We come back and we finish this one and give you more examples. Okay, see you then. Okay, so we continue. Just give you one more example of this group. Then that second shortcut that I talk about it about this trigonometric function, I talk about it later when we get to the application problems. Okay, so these are going to be our examples for the time being. Now, there is one important problem example that I should give you. This one is show you that sometimes you may have to do something extra. Again, in application problems in future, there are a couple of cases frequently you will arrive at this type of ideas when we go to the function of several variables in application problem in future or calculus 3, sometimes in calculus, calculus 1. So this is just one of them, just to get to know them for this group, just techniques that we have. There's no shortcut for this type of problems, okay? So this is the one in your book. I can give you several of those from my calculus 3 class as well, so that you will see it. Let's see how we're going to evaluate this integral, okay? So we want to evaluate this integral, of course, by substitution method. There is another method that we can take care of this type of problems in calculus 2. We call it the integration by parts, but of course, in this course, evaluate the integral by substitution. So, you cannot use those methods, but it's very nice. There are several of these that can be done. Look at this. You see, it's x radical x minus 1 dx. And there are a couple of them. I just write 2. So the other one is x squared radical x minus 1 dx. It can be any power, x squared to the third to the fifth. And these are the ones that you must know how to do it. Okay, let's see. You know that this there is a radical here, of course. So we have to switch radical. So we try. So the solution. I'm going to try the first one. So we have to rewrite it. It's going to be x times x minus 1, everything to the half dx. And now we know it so far that if it's going to be anything like a parenthesis here, the inside parenthesis, we are going to call it u, as we did it for all the other one. So we take the u to be x minus 1. Okay, this is going to be the case. And then, of course, we have to find the differential of the u. So we have to find the du. The derivative of x minus 1 is 1. So it's going to be 1, u prime is 1, times the dx. Okay, which is going to be equal to the dx. We usually solve for dx, so we already got the dx. So the dx and the du are going to be the same here. Okay, now go back and substitute to see what's going to be your integral. Okay, this is the integral that we have. So we have the x times x minus 1 to the half dx. So we substitute. We usually say we don't have anything for the x, and we hope to cancel it out, as we did for the other problems. So we are going to keep the x here. Okay, x. Then x minus 1. X minus 1 is u, so that gives you u to the, okay, that's going to be u to the half. Then we usually substitute for the dx, and the dx is du. You see, du. So the next step for all the other problems that we did, we simplify. You see, there is an x and x here, and there is nothing to be simplified. Okay, so you cannot remove the x. That will cause difficulty for you because you can't do it. When you do the substitution method, when you substitute, you must get your function must be a function of u. You may have the u and the dx. You see, x and the dx, or you can have the u and the du. So the difficulty is this x here. Okay, so what you can do in this case is you can change the x into the u as well. You see, look at this one. You see, your u is x minus 1. So what you can do is you can find the x from here in terms of the u. If you solve this one for x, x would be u plus 1. So you have to replace the x by u plus 1, then continue. Okay, this is another option that you should be aware of, and be prepared for it in case of this type of problems. Okay, so if you see it, it's very rare, but if it's going to be the case and you just know that you have to use the substitution method, so you have to go and bring the x for us. Okay, so oh, I can't do it for the moment, but I come back to it. So what are we going to do extra? The extra things is I get it from here. So I get the x from here. So my x would be u plus 1. So I'm going to here, not only I substitute for the dx and the u, but also I'm going to substitute for x. So I take this one. So it's the x, u to the half, and the du. Now I substitute for x. X is simply u plus 1. And I have u to the half du. You see now, this integral, it can be done because I have the du and I have the u's. Now, the way we do it, you need a little bit more algebra. The algebra is you have to distribute u to the 1/2 inside and then continue. Okay, so it's going to be equal to integral of inside distribute u to the 1/2 times u would be u to the 3/2. Okay, and u to the 1/2 times 1 would be u to the half. U to the half. And then we have the du here. Now we can do it. Just the power rule. U to the 3/2 is going to be equal to the u to the 3/2 plus 1 would be 5/2. And this would be the 5/2 plus u to the 1/2. 1/2 plus 1 would be u to the 3/2. U to the 3/2, okay, over the 3/2 plus the constant c. Any question? Now you have to switch its numbers, use the reciprocal. Okay, we use the reciprocal to be able to take care of it. So this is going to be equal to, it's going to be equal to the 5/2 would be 2/5. Okay, that would be 2/5 u to the 5/2. Okay, plus, and this would be 2/3. Okay, 2/3 u to the 3/2 plus the constancy. Now we substitute for u, of course. U is what? U is x minus 1. So the final answer is going to be 2/5. Okay, x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus the constant c, the final answer. Okay, so it's a very, very important problem, and you got to know it if you want to. Of course, when you get to calculus 2, we have a method of, we call it integration by parts method. It can be done by integration by parts, but when things get more complicated, really, for other cases, knowing this is nice. In calculus 2, you have this problem, and they ask you to do it. They give you 2 parts. Part 1, they say do it by substitution method. Even they give you the u. They say u equal to the x minus 1. Use the substitution. That's case 1. And the case 2, they repeat it again, but this time they say, oh, do it using integration by parts method. But the substitution one is interesting. Okay, so this is one of those things that it's very unique. You may not see it on your test because this is the only one that we have. In your assignment, in your book, they call this one 2x minus 1, the only thing that we have. But knowing it is very important for us, okay? Any question? So that's a very especially unique case. If you want to do the second part, you see the second part is almost the same, but you have x squared to take care of. So when we get to this part, this is u plus 1, you make it to u plus 1 squared. Then you have to square it. I can do that one too so that you have it because they are important problem. Okay, so let's quickly give you the solution of part 2 as well. It's good practice. This is something which is a little bit different and of course important. So the part 2 is x squared times x minus 1 dx. I quickly give you this one because I've already done most of the part of it. So I rewrite it. So this is going to be x squared times x minus 1 to the half. So the first part is the same. So I take the u to be x minus 1. Okay, remember the dx and the du are going to be the same. So we go back and we substitute to see the difficulty. This is x squared times x minus 1 to the half dx. So you don't have anything for the x squared, but x minus 1 is u, so that's going to be u to the half. Then for the dx and the du are the same. So the difficulty is x squared. So what you have to do is, again, you have to find the x here. So your x would be u plus 1. And then you go back and substitute. You got a little bit more algebra. So we have the x squared, u to the half du. Substitute for x squared, so that gives you u plus 1 squared, okay, u to the half and the du. Now u to the half, you see u plus 1 squared, you have to square this one first. That's your extra job. You can FOIL it, u plus 1 times u plus 1, or you can use the square of the binomial. I'm going to use the square of the binomial. So it's going to be u squared twice of the first times second plus 2u plus 1 times it by u to the half du. So multiply the u inside and integrate it. So it's going to be u to the 2 plus half would be 2.5, which is 5 half, plus 2u to the power 1 plus 1.5, or just 3 halves, plus u to the 1 half du. See, it's the same thing, but you get more to practice. Question. So integrate u to the 5 half would be u to the 5 half plus 1, which is a 7 half, over the 7 half plus 2 times u to the 3 half plus 1 would be 5 half over the 5 half plus u to the 1 half plus 1 would be 3 halves over the 3 halves. Of course, the constancy. Okay, use the reciprocal of those numbers. So this is going to be equal to reciprocal is going to be 2, 7 u to the 7 half. This is going to be 2 times reciprocal 2/5 u to the 5 half. And this is going to be 2/3 u to the 3 halves plus the constancy. Just substitute for u and then you're done. U was x minus 1. So that gives you 2, 7 x minus 1 to the 7 half plus 2 times 2, 4, 4/5 x minus 1 to the 5 half plus 2/3 x minus 1 to the 3 halves plus the constant c is going to be the final answer. Okay, I just want to give you these in case in future you want to take those courses. And otherwise, if you don't, you just know the method. So that's the only case that, otherwise all the other problem of the substitution method can be done with the shortcut really. But not this one, but the role of the differential and the way we do it, of course, is important. Okay, any question? Now, quickly to give you application problems, remember, the application is the case that if you want to solve a differential equation, as we did it the other day, and some initial condition would be given to you that enable you to find this C. So you did it, and you do have what on your quiz for that ordinary integral. And now you may have to do it for with the substitution method, okay? So give you one example to finish it, okay? And that's it. So example, application. Remember, rate of change would be given to you want to recover the function. Position function of a moving object would be given. You want to get the position of that moving object. There you are, solve. Okay, solve the differential equation. Solve the differential equation. And your equation is this one. Dy dx is equal to cube root 1 plus 7x with the condition that f of 1 is equal to the negative 2. Of course, we know that this y is equal to the f of x. Okay, the way we do it, remember, we change this one to the f prime. So f prime is given to you want to recover the f, you integrate it. So as you did it for the other problems. Okay, are you ready? Solution. We rewrite this one as f prime. So f prime of x is equal to cube root of 1 plus 7x. Initial condition of f of 1 equal to the negative 2. Okay, this antiderivative is given to you. We want to recover the function, so we integrate it. So f of x is going to be equal to the integral of cube root of 1 plus 7x dx. You see, automatically, you know it yourself. That you have to rewrite it, and when you rewrite it, you have to use substitution method. So you must recognize it yourself. Then you need the substitution method. You have no other choice. So this is going to be 1 plus 7x. Okay, everything to a third dx. Again, the short form, this will be very quick for this, but otherwise you can do it. You take the u to be, okay, this is going to be your u. So you take your u to be 1 plus 7x. Of course, you have to find the du. Okay, du, derivative of the u. If 1 is 0, derivative of 7x, 7. But times the dx. Then we find the dx, so the dx is going to be equal to du over 7. Okay, this is going to be the case. Go back, substitute, your target is u to the 1/3. Okay, so this is it. We continue with solving this one. So integral of 1 plus 7x. Okay, 1 plus 7x to a third dx is going to be equal to, that gives you u to the 1/3 times the dx, but the dx is, what's that? Dx is, sorry, du over 7. Du over 7. There is a 7 here that we cannot simplify it. So we pull out the 1 7 out. That gives 1 7 integral of u to the third, okay, du. Now we integrate it, 1/3 plus 1, so that gives me 1 7 u to the 1/3 plus 1 would be 4/3 over the 4/3 plus the constancy. But you have to use the reciprocal of the 4/3 to simplify it. So that gives 1 7. Reciprocal 4/3 would be 3/4. U to the 4/3 plus the constancy. So that is it. This is going to be 3, and that would be 28. Okay, so your function f of x is going to be, remember, you are looking for f of x. It's going to be equal to the 3 over 28, u 1 plus 7x to the 4/3 plus the constant c. So that's, remember, that's the one we call it general solution. So that would be general solution, but we have a condition that f of 1 equal to -2. So this means you have to continue to find the constant, okay, to find the constant c as we did it for the, okay, for the other one. So this is it. So that would be f of x, but we say we are not done. We say that f of 1 is equal to the -2. Okay, -2, so substitute x equal to the 1, okay. You substitute here, so that's going to be 3 over 28 times it by 1 plus 7 to the 4/3, okay, plus the constant c, which is equal to the -2. Okay, the inside one, 1 and 7 would be 8. So that gives it 3 over 28 times 8 to the 4/3. Okay, plus the constant c, which is equal to the -2. We have to simplify it. 8 to the 1/3. 8 to the 1/3 would be 2. 2 to the 4th would be 16. So that gives it 3 over 28 times 16 plus c equal to the -2. Okay, then what else we can do? We can simplify these two, so that's going to be 14, and that would be 8. 8 times 3 is 24. So that gives you 24 over 14 plus c equal to the -2. So c would be -2 minus 24 over 14. So the c is 28 minus 24, which is, I didn't make any mistake. That's it. Oh, so -2, -24. So that gives us a -26 over, what is that? That's correct. Yeah, that's a 16. 16, and I simplified by, yeah, you can, I know I can simplify that further. So that give me -26 over 14. Okay, which going to be negative, because that's a -28. Sorry, I just didn't simplify it here. Okay, that's it. It's going to be 28. It's going to be 14, and that gives me -28 minus 24. So the final answer is going to be what? Is a negative, and that would be 52 over 14, which is equal to the -26 over 7. I think that's correct. Okay, I made a mess because I should simplify this one further, but it doesn't matter. So you go back and substitute here. So the final answer is f of x is equal to the 3 over 28, okay, times 1 plus 7x to the 4/3, okay, and the c. C is 26/7, the final answer. Okay, so just show you the application type that we are going to have. Okay, that is going to be then the thing. Okay, any question? So that is the U substitution. Okay, the method that we are going to have. Again, we come back to it. This one later on. There is one more type of integrals that we can have one more example. Otherwise, we are ready for it. So we just switch the method. Okay, so we talk about it now to get these numbers done. Okay, any question? So that's a 4.5. Now, what we are going to do for the rest of this chapter, remember what we did so far. We just look at the integral as a machine. Okay. So it's like differentiation. We didn't talk about any other idea, application problems. We just did a couple of them. But at the beginning of calculus, we talk about that the calculus is dealing with two types of problems. The first problem was the tangent line problems, okay? And the second problem was the area problem. We did the tangent line problem already. Okay, the slope of a tangent line is derivative of the function, and we read the equation of the tangent line and be done. We are going to do the same thing with the integrations. The way I did it, or we did it so far, we just introduced the machine. Now, how we're going to connect this machine to the notion of the area and the curve, if you like. You know, a region would be given to find the area of that region. You see, if the region is a triangle, you know the area. If it's going to be a circle, you know how to do it. But the difficulty is, you know, if you go to the beach, the area of the beach is not going to be just a rectangle. Sometimes you may get a curvilinear one. So how are we going to do those type of problems? So this is the way we are going to be for the rest of this chapter, introducing applying the notion of integral to get to the area problem, okay? So we go back to 4.2. Eventually, we are going to get the area. You got to be patient because we don't want to accept it. There are a couple of methods that it takes time a little bit to know it. But at the end, there are going to be short form, shortcut for this. And you have to know the method, especially the one that I'm going to talk about it. Okay, so let's give you a little bit idea today, and then we try to finish it tomorrow. It's a very long section. 4.2, the notion of integral. So from now on, you can sit back. Okay, you already got the machine. So sit back, enjoy the kind of application. If you are going to be math major, you will see some concept that need to be proved. Okay, and this is the way we are going to generalize these methods for the function of 2 variables and 3 variables in future. Again, if you intend to take calculus 3, of course, this section is very crucial for you. But in general, it's a very good one, okay? So going back to the 4.2. Don't be surprised that I'm just moving through these sections because of your book. This is the way it got to be. Now, what is 4.2? That great problem. How are we going to solve the area problem? That's it. The second problem in calculus. What is going? It was the first problem in calculus, but the way we do it today, it's going to be the second. So what's the area problem? The area problem. Okay, so we would like to find the area of each region. Find the area of each region. That's it. So let's see. The first one. If your area is a triangle, this is the area you are interested in. Region. Your region is it's a triangular region. How are we going to find this area? Any suggestion? Remember area of triangle? Who knows the formula? Area of a triangle. What we need the height. This is the height. Okay, you call it height. And this is what? This is the base. We call it B. Now we know that the area of a triangle is what? So the solution for this one is that the area of a triangle is what? Is a 1/2 of the product of the base times height. Okay, that's the area of a triangle. So if it's a triangle, you don't need calculus, we can do it. Area of a triangle is going to be 1/2 of the base times the height. Any question? So we're done with first one. What's the second one? The second one is, suppose you want to do the area of a rectangle. Okay, that's going to be a rectangle. Rectangle. We know there is a formula for this one. But the way we would like to do it is, suppose you know how to do the area of a triangle. How are we going to use this one in order to find the area of a rectangle? Any suggestion? Okay, suppose you know to do the triangle. So how are you to use the idea of a area of a triangle to find the area of this rectangle? Any suggestion? If you know how to do the triangle. If you want to do the rectangle, just using idea of a triangle. So what you can do is you can partition it. That's it. You see? So I can divide it in two parts. I can divide the rectangle. This is the way they did it historically. So we just want to follow the history. And at the end, we get something that, would be of interest to us. Okay, we don't want to rush. We want to get the idea. That's why. Okay, so I can divide two parts. So I divide two parts. So this is going to be the first triangle. It's going to be A1. And this is going to be A2. Okay. So now I can do it. I can find the area of each triangle and just add them together. Okay, so A is equal to the A1 plus A2. Okay, so if I know the area of a triangle, then I can divide this one in two parts and add the areas together. But you know that there is a formula for this one. This is it. Actually, we don't do it. This is going to be the L and the V, okay? So this area is going to be L times W. But that idea is important for us, that we can divide in two parts. Okay, any question? So I can do the triangle. I can do the rectangle. So what's going to be the next area? Suppose you want to find the area inside a kind of a polygon. This one. Look at this one. Okay, kind of. This is going to be the case. I'm sorry, I just made a mistake. This one. So this is the one. Okay, I can draw it again. This is the one. Okay, again, we know that there is a formula for this one, but we don't want to use it. Suppose to know how to find the area of a triangle. So knowing this one, how can you find the area of this, inside this polygon? Again, you see the same method that I did. We can easily cover this one by rectangles, triangles. So make some triangle. 1, 2. Okay, that's 1 more. That's going to be 3 and 4. So I got the A1 here. You see the A1, A2, A3, and A4. So now we know it. I can add them together. So that give me A1 plus A2 plus A3 plus A4. And we know that there is a formula for it that we don't care. So that idea is giving, we're getting number. It's a very, very important one, just to partition it by different parts. Okay, any question? Now, these examples that I gave you, all the sides of the region are straight lines. You see, straight lines. We call this region a rectilinear one because the sides are just a straight line. Okay, so what we would like to do, when we go to the beach, it's not going to be just a straight line all the time. So we may have a curvilinear one part, okay? So this is going to be the case, number 4. Okay, the number 4 is, suppose you have a curvilinear one. And the most interesting curvilinear one is just a circle. So how about the area of a circle? You see the area of a circle? Again, we want to use these ideas, of course. We know that the area of a circle is pi r square. But if you want to use this idea, what you can do is you can cover it. You can estimate it. You see, these are exact value. In the case of the circle, we cannot get those triangles right away. But what we can do is we can estimate. This is calculus. In calculus, we estimate. So what we can do, the same idea over here. So, I'm going to partition it. You see, this is it. I'm going to cover it. Okay, I'm going to cover this one by a polygon inside. Okay, that's it. I can do it from outside as well. So what can I do is I can find the area of the inside. If I call this area of the inside A1, so I can do it like this, but you know that there's going to be some leftover that I didn't cover. So these are going to be the leftover. You see, these are the leftover. These are going to be the leftover. So in that case, the area inside A1 is not going to be exactly the area of a triangle, the inside. So it's going to be almost equal to the A1. So we can only estimate it. Okay, we can estimate it to get these numbers. Okay, but what are we going to do to, this is too much. Okay, too much to lose. Because when you estimate, you may lose or you may gain. It's like rounding. Okay, in this case, you lose quite a lot. So what we'd like to do is we'd like to partition it so that the amount that we're going to lose is going to be very much, very low, very small. So what we can do is we can increase this number of the partitions. So if you have the same circle over here, okay, if you increase the number of the partitions, okay, just put them closer together. Okay, this is going to be what? If you just cover it in this one, for example. You see, this is much better. So again, you can call this one A2. So you get a better estimate if you estimate it with A2 here. Okay, so as you can see, the leftover over here are going to be much less. Okay, so what we can do is if you just increase this number of the partitions over and over and over, okay, so what you are going to do, for example, end up is going to be, you get a sequence of numbers if you increase these partitions. So you're going to have the numbers that you get, the first one, you may get the A1 here, a number, then you may get the A2. If you increase the partition, you get the A3, you can go on forever, okay? Forever means as you move on, your area is going to be closer and closer to the A that you are going to be interested in. But it's going to be very much closer if n is very big. So very big means what? Mean n is going to the infinity. You know that in the language of calculus, this means the limit of an when n goes to infinity, okay, is equal to the a to get these numbers. Okay, and so this idea was for the first time was done by Archimedes, and he used this idea in order to find the area of a circle. Of course, not the formula, just the exact, that's estimating numerically. You know that the form of the pi r square for the first time was done by Chinese. But the idea of the Archimedes enabled him not only to find the area of the, inside the area of a circle, but he was again, able to find even the volume of some three-dimensional solids that are going to have. So he called his idea the method of exhaustion, if you like, because you are going to increase the number of partitions so that you remove all those leftover that you're going to have. And this was the kind of birthplace of calculus, really, because this problem of the area was done first, then the derivative one. So what we are going to do is we are going to use this idea of the Archimedes to be able to solve our problem of the area under the curve. Of course, these are all geometry. So the curve that we are going to be interested in calculus is the graph of the function, of course. Okay, so our main problem. So that was just your idea, to give you the idea from, history of calculus. Very important one. You can search on internet for yourself. If you search on internet, just put the Archimedes problem or just the method of exhaustion for the Archimedes. You will see all sorts of partitionings and different regions that the people try and give you something very colorful, even in three-dimensional cases. But that would give us, take us, or give some idea of how we're going to handle our problem. You see, our problem, which is going to be the next one, number 5, is this famous area problem. Okay. Again, as I told you, we are not going to rush this section, but you got to be patient. At the end, we are going to create a machine that take care of everything for us for a matter of seconds. But this is the idea of a very important part of your course that you have to know it. So number 5 is the problem is this one that we call it the area problem. We give a function. So this is it. We'd like you to find. This is the problem that we have to handle. Find the area. Find the area of the region. Area of the region enclosed by. Enclosed by the graph. Enclosed by the graph of the function. Graph of the function y equal to the f of x. Okay, from x equal to the a to x equal to the b. You see, that's the problem. We call it the area problem. So what does it mean? This means this is going to be, for example, the graph of your function. Suppose this is the graph of your function. And from a to b means this is x equal to the a. Okay, and this is x equal to the b. Okay, x equal to the x equal to the b. And the area in question is this one. We call it area under the curve. Okay, so that's going to be a region that's enclosed by, okay, it's a region that's enclosed by y equal to the f of x. Okay, y equal to the f of x, x-axis, and the vertical line x equal to the and x equal to the b. Now the way we're going to do it, we are going to use the idea of the Archimedes. We can't do it as is. So what we do, we are going to cover it. We can cover it with, with the rectangles, we can cover it with the triangles. So the way we're going to cover it, we are going to cover by some rectangles. Okay, so this is the way we do it. Solution. This part that was done by the great German mathematician, his name is Riemann. And this result is going to be called the Riemann integral in future. Okay, again, you can check his name Great mathematician, has done quite a lot. Riemann hypothesis is one of those things that we know. There's a part of mathematics, complex analysis, quite a lot we do with the name of the Riemann. And this is his best, or it can be done, it's just elementaries. It can be done in more details. Okay, so what I'm going to do is the idea of Riemann is he just used the idea of the arguments. So we are going to partition this part, okay, divide it into different parts. So the way I'm going to do it is going to be, you see, we need some, let's do it, then we give you more information, partition it. That's it. So I start with the A and the B. So this is going to be the graph. And this is A. This is B. Okay, A and the B. So what we do is we can partition it different parts. Okay, we can partition equally. I'm going to partition it equally. Okay, that's going to be equal partitions. Then I draw some vertical lines. Can do quite a lot just to start with. Then I can make some rectangles. You can make rectangles from inside or outside. I'm going to cover it from inside. You see, I cover it from inside. So I'm going to cover everything. You see, this is it. Okay, so I'm going to cover it with different rectangles. So in order to find the area in question, I can find the area of the rectangle inside and add them together. So eventually the area in question is going to be, you see the area is going to be almost like the area of the first rectangle, the second rectangle. And in order to take care of those leftover, as I did it for the circle, we can increase the number of the partition. So eventually this is going to be the one. Okay. So I can make it short. We use the sigma notation, if you are familiar with the sigma notation. So this is going to be almost like the sigma. Sigma means sum. This is going to be AI, I from 1 to n. Okay, but in the language calculus, this would be what? This would be A equal to the limit of, okay, the limit of the sigma of AI, I from 1 to n, and n go I from 1 to n, and n goes to infinity. You see, that's a basic idea that we got the same one from the work of the Archimedes. But as you can see, this formula is not going to be easy to operate. So if you want to do it, you have to look at one of these rectangles, take this one of these out, and define the area of the rectangle. You see, if you take one of them out, so let's take one of them out. You see this one of those bits out. This is going to be the one. So you know that the area of the rectangle is going to be the product of the dimension. This dimension we divide to equal parts. So each part is going to be called delta x. So this is going to be, we call it delta x, a change in x, because you go to the right to the left. And this part over here is going to be what? You see these points are going to be on the, okay, on the curve. So it's going to be y coordinate of a point, if you like. So any points. So what I'm going to do is, I'm going to pick one point here. Okay, I call this point CI. And this is going to be f of CI. Okay, so for each triangle, the rectangle, the area of a rectangle is going to be the product of a dimension, which is going to be f of CI times delta x, roughly. I'm going to explain it more details in a minute. And so basically, now your formula is going to be A is equal to the limit of sigma of f of CI times delta x, I from 1 to n goes to infinity. You see, roughly, this is going to be the area and the curve. Of course, we are going to change this formula into the easier one, but just give you the idea for the time being. Of course, this is not going to be easy to handle. We have to give you a little bit more information to see how we're going to do it, but basics going to be the same. You see this f of ci delta x. So look at the between a and the b. This is a, this is b. So what we did here, we just divide them into equal parts. So let's divide into equal parts. You see, equal parts. It can be done in different format, but I'll just give you roughly one case. These are equal parts. So what we do, the first part, the first point A, we are going to call this one x0. This is going to be called x1. This is going to be x2, x3. You go up to the xn. See, we have a partition of points. So the way you did it, you start with the A, which is the x0. Okay, this is going to be the x0. So this is going to be less than x1, less than x1, less than x2, x3, up to the, xn. You see, you can divide into 5 parts, 6 parts, 10 parts, 100 parts. So we say we partition it. So we partition it is between A and the B. So this is the way you do it. You did it. So first thing to do, you have to find this delta x. And delta x is going to be these portions that you have over here. You see, each of these portions, this portion that we have, each of these are going to be delta x, delta x. Now the way we're going to find it, you see, if you go from, if this is going to be 0, this is going to be 5. This the length is going to be 5. So in general, in order to find the delta x is going to be, you see, all of them together. So I just move it here again to explain it. You see, this is going to be A and the B. This distance is basically B minus A. And the delta x is going to be equal to the B minus A over N. This is one formula that we have to know. Okay, it depends how many times, how we're going to divide it. If this is going to be 0 and 5, the length would be 5. If you want to divide by 10 parts, it's going to be 5 over 10. Divide by 100 parts, 5 over 100. So this delta x that we talk about it is going to be B minus A over N times delta x. So when we use this formula, you know that what the delta x is. Okay, this is 1. Any question? Now what's going to be this CI? You see, this CI is going to be a point inside one of these intervals. It can be any point, but I'm going to pick one nice one for you to be able to give a couple of examples. Okay, so let's go to the next page, identify the CI for you. You see, again, there are different CIs, but it just give you one case to understand it. You see, again, look at this one. So that's A, B. Remember the total was B minus A, so you have the delta x. Delta x is equal to the B minus A over A. So you pick your first point, which is A. Then you travel how much? Delta x. To get to your first point here, which is x1. So your x1 is, you go from left to right. A plus 1 delta x, that give you x1. In order to get to the next point, you just move on. Another delta x that give you x2. So your x2 would be, you start from the A plus 2 delta x. This is going to be your x2. And then you just keep going. x3, okay, delta x. x3, is going to be a plus how many delta x? 1, 2, 3. 3 delta x. That's it. And you just keep going. So remember, for the 1 is 1 delta x, for the 2 is 2, for 3. So what I'm going to do is, if I stop somewhere like xi, it's going to be a plus I delta x. I delta x. What I do is I'm going to pick this one to be ci. So suppose ci is okay, is optional. I take the ci to be a plus I delta x. This is going to be for I equal to the 1, 2, 3, up to the n. Okay, so I gave you the formula. So the area so far, it's very a special case that I'm going to talk about. You see, so the area so far is the limit of sigma of f of ci delta x, I from 1 to n goes to infinity. Use this one formula where delta x is equal to the b minus a over n, and ci is going to be equal to the a plus I delta x, or I is equal to the 1, 2, 3, up to the n, to be able to do the job. Okay, I did everything. Just show you, just to motivate it. Now we are going to take this one as a definition of the area, and then work on this one to get, we are going to develop this, and we change it to the integral, tomorrow. But I'm going to make it official. Any question? Just read this through. We didn't want to rush, okay, to get the idea, but everything would be fine. Just don't worry. But you have to get the idea and to do it once for us, because you need it. Right at the beginning of calculus 2, they talk about it, and in calculus 3, quite a lot. So that's the conclusion that what I did. We call it a definition. So we haven't solved the area problem, but we have a plan. There you are. If a function f is going to be continuous, and of course positive, continuous, and non-negative. Non-negative on the closed interval of a and b. Then the area of a region, the area of the region bounded by the graph, of y equal to the f of x from x equal to the a to x equal to the b is given by just the formula that I proved. A equal to the limit of the sigma f of ci delta x, I from 1 to n goes to infinity. We use it for a special case where delta x is equal to the b minus a over n, and ci is equal to the a plus I delta x. These are the dimension of the, they're going to be used for the dimension of those rectangles. So delta x is b minus a over n, and the ci is a plus I times delta x for I equal to the 1, 2, 3 up to the That's it. I just made up everything we need, and we leave it for tomorrow. We started over. We haven't done anything for this in this section. We just introduced, give you the motivation. So we know that we give you one example on this one, then you will see that it's not going to be easy to work with. Then we change it to the notion of the integral. When we change it to the notion of the integral, we have a new integral, we call it definite integral, and you already got all the formulas. So as soon as we change it, it's so familiar for you. It's not going to be anything strange. So work on the substitution method. That's my recommendation. Leave this one for tomorrow. So work on that substitution method quickly, and I will post your practice. It's going to be practice test number 3, and you get quite a lot of those substitution. If we finish this one tomorrow, and there's a couple of theorems, and then we get changed to practice. So by Wednesday, we finish this chapter, and your test would be up to the end of this chapter. Okay, that's it. If you have any question, I'll talk about it on your test. Email me. You can come to the Zoom, and you can discuss any problem that you have about the test. Okay, otherwise have a good one, and remember you have to make an appointment for your test. So just make an appointment, and make an appointment for your final in advance, because they are going to be very busy. Okay, so we can do that one too. Okay, so have a good one and see you tomorrow. Work on the substitution method. Bye-bye.